Laser weapons once lived in the imagination of sci-fi movies and comic books. Today, they are quietly stepping into real-world battlefields and defense strategies. The United States alone has invested more than $7 billion in directed energy programs since 2017. Over the last year, American warships have burned hostile drones out of the sky using silent beams of light. Israel is preparing to field a laser defense that destroys incoming rockets for the price of a cup of coffee. China displays rotating laser turrets at military parades. Russia claims it can blind satellites orbiting above Earth. In the background of global military modernization, a new stealthy competition is underway. Missiles still roar, guns still thunder, but the next wave of warfighting technology does not make a sound. This is the global laser arms race. Who's building them, how they work, and why the future battlefield may run on electricity instead of ammunition. High-energy laser with integrated optical dazzler and surveillance. The United States Navy spent decades exploring lasers, but only recently achieved meaningful success. In 2024, the Navy announced that high-energy laser with integrated optical dazzler and surveillance a 60-kilowatt directed energy system mounted on the USS Preble had shot down a drone during live fire trials. No missile trails, no thunderous blasts, just a beam of light melting airborne hardware. High-energy laser with integrated optical dazzler and surveillance is not an experiment sitting on the deck. It is wired into the Aegis combat system, allowing the ship to track, lock, and fire using the same brain that controls its missiles and radars. The weapon replaced the forward gun of the destroyer and is designed to scale up to 120 kilowatts as technology matures. The logic behind the project is simple. Modern ships face swarms of low-cost drones and explosive boats, particularly in hotspots like the Red Sea. Firing a $2 million missile at a cheap drone is not a sustainable strategy. A laser shot costs only electric power, and its magazine never runs dry. U.S. Navy leadership has repeatedly stated that the goal is not to replace missiles, but to preserve them. Lasers act as the first shield layer, destroying inexpensive threats cheaply and saving missiles for the targets that matter. High-energy laser with integrated optical dazzler and surveillance is still being tested, but it represents the most successful U.S. naval laser deployment so far and opens the door for future systems across the fleet when lasers can't fly. Laser weapons at sea are one thing. Mounting them on a jet fighter is another challenge entirely. The U.S. Air Force attempted to create an airborne laser defense called the Self-Protect High-Energy Laser Demonstrator. The idea was revolutionary. Attach a small laser pod to fighters like the F-15 and let it shoot down incoming missiles. On the ground, the system worked. The laser module from Lockheed Martin, the optical tracking from Northrop Grumman, and the aircraft pod from Boeing all functioned individually. But they never flew together. The challenge was not technology, it was physics. Fighter jets simply do not produce enough spare electrical power or cooling capacity to run even a 50-kilowatt laser. Engineers estimated that powering the system would require roughly 250 kilowatts of onboard capacity, far beyond what current fighters generate. Without enough electricity or cooling, the system could not survive airborne conditions. In 2024, the Air Force ended the program without ever mounting the system on a jet. A similar attempt to install a laser on AC-130 gunships met the same fate. Airborne lasers are not dead. They are simply waiting for aircraft that can generate the power they need. Sixth-generation fighters currently in development are expected to include space and power capacity for laser systems from day one. Israel's Iron Beam. Among all nations racing to adopt laser weapons, Israel is the closest to fully fielding them in combat. The Iron Beam system, developed by Rafael and Elbit Systems, is expected to enter service by the end of 2025. It fires a 100 to 150 kilowatt beam that destroys rockets, mortars, and drones, the types of threats Israel faces constantly. During testing, Iron Beam destroyed rockets and unmanned aircraft in seconds. It links directly to the existing Iron Dome network, sharing radars and command systems. What makes it revolutionary is its cost-to-kill advantage. While a traditional interceptor missile from Iron Dome can cost tens of thousands of dollars, An iron beam shot costs only electricity, approximately $2 per engagement. In a world where cheap explosive drones are becoming standard battlefield tools, this cost gap is not simply beneficial, it is transformational. Iron beam turns mass-produced munitions into a bad investment for attackers. Israel is already exploring mobile versions for armored vehicles and airborne variants for future aircraft. Silent Hunter and the LY-1 turret. China has aggressively displayed laser capabilities to signal its rapid progress. Its earlier system, Silent Hunter, is a 30-kilowatt truck-mounted laser designed for short-range defense. Unlike many experimental systems, Silent Hunter has been used in the field. In 2024, Saudi Arabia deployed it to down a hostile drone targeting critical energy infrastructure. The system's mobility and rapid deployment make it suitable for airbase and facility protection. But China's biggest statement came in late 2025 with the unveiling of the LY-1, a rotating ship-mounted laser turret reportedly capable of 180 to 250 kilowatts. If true, LY-1 would be the most powerful naval laser ever shown publicly. The system has appeared on amphibious ships and armored trucks, suggesting China is testing both land and sea deployment options. The turret appears physically large with an aperture that hints at high beam quality and long-range targeting capability. However, unlike Israel and the United States, China has yet to publicly release confirmed footage of the LY-1 destroying real targets. Until the system demonstrates combat-credible performance, analysts consider it powerful but unproven. Russia's laser strategy. Russia has taken a different path with its laser research. Rather than focusing primarily on drone defense, Russian programs emphasize satellite blinding technology. The Peresvet system, first shown in 2018, is designed to interfere with satellites and reconnaissance systems near strategic missile sites. Russian officials claim it can blind satellite sensors up to 1,500 kilometers away, protecting mobile nuclear launchers from detection. However, like many Russian military claims, this capability remains unverified publicly. Russia also announced a tactical laser called Zadira in 2022, allegedly capable of destroying drones at several kilometers. Officials said it was used in Ukraine, but no confirmed footage or independent verification has ever surfaced. Ukrainian officials dismiss the claims as propaganda. Russia's lasers remain shadowed in uncertainty, potentially real but lacking the transparency and proof demonstrated by US and Israeli systems. Why lasers matter, despite their limits. For all the progress, lasers still face hard limitations. High-energy beams require large, stable power supplies and sophisticated cooling systems. Rain, dust, fog, smoke, and humidity scatter laser beams and reduce effectiveness. Ships are naturally suited for laser deployment because they generate enormous electricity and have space for cooling machinery. Jets, by comparison, have tight weight and power constraints. And even ground systems must contend with dust, weather, and maintenance issues, and especially dirty optics. So why are nations racing to build laser weapons anyway? Because modern warfare is being reshaped by cheap drones, mass-produced rockets, and saturation attacks. Traditional missile interceptors are effective but extremely expensive. Lasers flip that logic. They are silent, fast, and cost pennies per shot. They are not replacing missiles. They protect missiles by saving them for high-value threats. The future battlefield will not abandon explosives, but it will increasingly rely on energy-based defenses. A future powered by light. The era of laser warfare has begun quietly. Ships now hide energy weapons behind steel plating. Air forces redesign future jets to carry laser pods. Ground units prepare for electric defense shields. Nations are not fighting laser wars yet, but they are building toward a world where electricity becomes ammunition. The weapons of tomorrow may not scream. They may not boom or flash. They may simply hum, heat, and cut through metal at the speed of light. In an age where drones can be built in a garage and rockets bought for a fraction of what it costs to stop them, laser weapons are not just futuristic, they are necessary. They do not need to be perfect. They only need to save missiles, destroy drones cheaply, and fire again and again. And for the first time, that future is no longer science fiction. It is quietly arriving, one beam of light at a time. If you enjoyed this deep dive into the new age of military technology, make sure to hit that like and subscribe to the channel. Drop a comment below and tell us, which laser system do you think will dominate the battlefield first? Thanks for watching, and stay tuned.